Nearly 100 million years ago, mammals and dinosaurs were still competing for their place on Earth. Dinosaurs reigned, yet mammals have carved out a niche in the nocturnal world. Some mammals even preyed on dinosaurs before falling to a new breed of deadly and cunning predators who hunted in packs. On top of this, dinosaurs are growing larger, living longer, and even flying. Yet somehow, against these odds, mammals were prospering. When the final card is dealt, they'll have the winning hand. And even the king of dinosaurs, Tyrannosaurus Rex, will fall. It's midway in the evolutionary battle between mammals and dinosaurs. And mammals are on the rise. Liaoning Province is in northeast China. It's a hotspot for researchers from around the world looking for prehistoric fossils. Here, the history of many dinosaurs and mammals is contained in the stratified cliffs that rise to almost 30 feet. The strata corresponds to the midpoint of the battle between dinosaurs and mammals that took place millions of years ago. This period was a mystery among researchers for a long time. But now, these geological beds have provided a valuable window into the era of dinosaurs and mammals. Paleontologist Qiang Ji has worked the area for over a decade. And on the rock slabs, researchers find one fossil after another that lived here 125 million years ago. In those days, this area was a lake. Dead plants and animals, carried in by rivers and streams, would sink to the bottom where they would become entombed in silt and mud and fossilize. Fossils of more than 300 different species were discovered. This is the reptile Hyphalosaurus, a long-necked lizard. In a turtle fossil, not only the shell, but also the bones of its limbs are well preserved. Many small insects were also found here. The site is one of the few where you can find insects in their entirety, preserved in fossils. Researchers have found some fossils so well preserved that delicate wing patterns can be identified. For the first time ever, the Liaoning discoveries revealed the life of a prehistoric world 125 million years old in extraordinary detail.
Liaoning is a unique treasure house of fossils. Even small insects or small underwater organisms that normally escape preservation have been discovered here. Larger animals that preyed on such small life forms are also preserved. It means that a whole picture of the environment and the ecosystem of this area in the past is perfectly preserved, as if they'd been taken in snapshots.
At the Chinese Academy of Sciences, scientists study a Liaoning fossil that has rewritten the history of mammals. The fossil, Repenomamus, is almost 20 inches long and the first evidence of a mammal larger than a mouse. It changed the common view of mammals throughout the age of dinosaurs. Repenomamus was the size of a small dog and the largest mammal of the Cretaceous period over 125 million years ago. It was up to 3 feet long and might have weighed as much as 30 pounds. It was not only the size that was remarkable about Reponomimus. Researchers were stunned by other fossil evidence. In its stomach were tiny fragments that turned out to be dinosaur teeth of Psittacosaurus, a small plant eater. Reponomimus, a mammal, was eating dinosaurs. These mammals were not victims, but instead aggressive hunters of dinosaurs. Mammals had started to strike back. The fossils from Liaoning also painted a detailed picture of that ancient world for the first time. A place of lakes and forests supporting a variety of wildlife, including Reponomimus. Here he prowled during the day, not hiding in the evening darkness like most mammals. Daylight hunting was essential in finding sources of food to maintain his relatively large body. On the prowl, the mammal runs into Hyphalosaurus, an aquatic reptile of 2 to 3 feet that was quite common in Liaoning. For the mammal, the reptiles are of little interest, and it must look elsewhere for food. The mammalian hunter strikes pay dirt when he stumbles on a brood of young Psittacosaurists, a fast-moving plant eater. Like all predators, Reponomimus goes after the most vulnerable, while the terrified young rush back to an adult. The juvenile dinosaurs lack the ability to fight back, but an adult is a different matter. Up to 4 feet tall and 175 pounds, a full-grown Psittacosaurus is too much for this mammal to handle. For years, this period of mammal and dinosaur evolution was a blank page, but no one had ever imagined that there were mammals that preyed on dinosaurs. Mammals were evolving and changing, but then so were dinosaurs, and that spelt real trouble for our ancestors. In 1996, Liaoning was once again home to another great find. The discovery of a fossil over 3 feet long introduced paleontologists to Sinosauropteryx. Its discovery dramatically changed our understanding of dinosaurs and their evolutionary history. On the fossil, something dark seems to cover the surface of its body, and many fine lines that look like scratches could be seen. They were primitive feathers, less than ½ inch long. These proto-feathers covered the neck and most of the rest of the dinosaur. Researchers had believed that since dinosaurs belonged to the reptile group, they would be covered with scales. But now, the discovery of the existence of feathered dinosaurs would forever change the way scientists looked at dinosaur evolution.
It was not only the mammals that experienced a dramatic evolutionary transformation. Dinosaurs had also achieved a revolutionary change in evolution. In Liaoning, various kinds of feathered dinosaurs have been found. In fact, when we compare the amount of fossils discovered here, far more feathered dinosaurs have been found than mammals. This means that it was the feathered dinosaurs that dominated the land of Liaoning. They lived in groups like modern wolves and established their position in the ecosystem as ferocious hunters.
Liaoning, 125 million years ago, was the land of feathered dinosaurs and a variety of types hunted in its forests. Sinosauropteryx was one of them. It shared the forest with other feathered creatures. The biggest, Dilong, was a hunter over 5 feet tall and one of the largest feathered dinosaurs ever found in the region. A deadly predator whose name means Emperor Dragon, Dilong was also a distant relative to the king of dinosaurs, Tyrannosaurus rex. It hunts in packs, and today's prey is Reponomamus. The dinosaur hunting mammal is now the hunted. Dilong is agile and swift. The dinosaur hunter doesn't have much of a chance. The mammal is helpless and no match for these predators with their massive claws and razor-sharp teeth. They were deadly killers, and no mammal was safe when they were about. Dinosaur carnivores had evolved into formidable hunters. But what was the importance of feathers? How did they help dinosaurs stay on top of the food chain? A look at some of today's animals might shed some light. Mammals can live in vastly different climates. Polar bears thrive in the frigid temperatures and harsh weather of the Arctic, and many types of mammals are found in the searing heat of Africa. It's the fur or hair on mammals that helps regulate their body temperature in a variety of climates. Even a lion's thick mane helps in stabilizing body temperature to a certain level, regardless of temperature changes in the environment. The ability of animals to stabilize their body temperatures is endothermy. It allows mammals to quickly convert digested food into heat energy to keep warm. Also, hair or fur helps prevent heat energy from escaping the body, enabling high motor activity in many animals. On dinosaurs, such as Sinosauropteryx, it's thought that feathers provided a similar function to a mammal's fur. At one time, most believed that all dinosaurs were like today's reptiles and amphibians, absorbing energy directly from the sun in order to become active. Day or night, the ability to move about was never an issue for endothermic mammals. Even 150 million years ago, Laolestes had no problem searching for food in cooler nighttime temperatures. The fur that kept them warm was part of a robust support system for primitive mammals to survive during the age of dinosaurs. Yet with the introduction of feathers, predators such as Dilong could now produce the energy that allowed them to move swiftly, anywhere and at any time. Zhang Zhu of the Chinese Academy of Sciences firmly believes that feathered dinosaurs must have been able to regulate their body temperature like mammals. His evidence, a feathered dinosaur named Mei Long, Chinese for soundly sleeping dragon. The dinosaur died when fast asleep. Its sleeping position provided proof that feathered dinosaurs were endothermic.
The head sticking out from the torso is the place where heat easily escapes from an animal's body. However, when Mei Lung tucked in its head under a feathered forelimb, it was a behavior that showed how these dinosaurs tried hard to maintain their body temperature. Therefore, their sleeping tells us that the feathered dinosaurs were endothermic, just like mammals, and that Mei Lung carefully adopted the best sleeping position for keeping warm.
Feathered dinosaurs took advantage of their ability to regulate body temperature to become very active hunters. Hunting in packs, feathered dinosaurs like Dilong were fast, agile, and terrifying. The dinosaurs roaming the lakeside forests of Liaoning came in different sizes and shapes. Here, feathered dinosaurs had opened the door to new evolutionary possibilities. Mammals were still land-bound, while Dilong and company were reaching for the heavens. No longer were feathers just about maintaining body heat. They were helping dinosaurs open the doors to the world of flight. Microraptor is believed to have lived in the forest canopy, where it glided from tree to tree. Feathered dinosaurs would make the sky their domain, and early in the Cretaceous period, the first birds were aloft. For the first half of the battle between dinos and mammals, dinosaurs were still on top, and feathered predators were presenting new challenges to mammals. So how could mammals possibly prosper in this world? Flower power was the answer. Today, we enjoy flowers for their beauty. But millions of years ago, they were a driving force in the eventual rise of mammalian domination. In Liaoning, a fossil nearly a foot long of the plant Archifructus was found. It is the earliest known flower to appear on our planet and belonged to a group of plants called angiosperms. From the shapes of its leaves, it's believed to have inhabited shallow water habitats, favored by many dinosaurs. While flowering plants would eventually thrive throughout the world, Archifructus in its early days probably lived on the margins of an ecosystem dominated by gymnosperms. At the beginning of the age of dinosaurs, more than 200 million years ago, the land plants were ferns, pines, cedars, and other gymnosperms. They helped feed Supersaurus and other dinosaurs in their constant quest for food, and the dinosaurs had quite an appetite. Sometimes Supersaurus would stand outside a forest, taking advantage of its long neck to reach and gather food while avoiding bogs or marshes inside. They could eat up to 1,100 pounds of food per day. It was in a world of ferns, cedars, and pines where Archifructus first made its appearance 130 million years ago. The first flowering plants would change forever mammalian evolution. Today, we take for granted flowering plants. But when they appeared during the age of dinosaurs, they created an environment that would allow mammals to succeed. And it was all possible thanks to insects. Flowering plants use insects to reproduce. A blooming flower lures them in with nectar, and while gathering it, they are smothered with pollen from the stamen. When insects move to another flower for more nectar, their pollen-covered bodies become the delivery system for fertilization. The insects, searching for more food, deliver pollen to the pistils and fertilize the plants. Gymnosperms, the dominant plants during an earlier age, relied on wind to carry their pollen. flowering plants had started a revolution in reproduction methods, and they also had a tremendous impact on insects. During the days when gymnosperms dominated, insects were limited to dragonflies and grasshoppers. Bees, butterflies, and many more insects appeared after the introduction of Archifructus and other flowering plants. Flower nectar provided a new food source for insects, and that triggered some dramatic evolutionary changes in them. Insects would now come in all sizes and shapes. Flowering plants and insects developed symbiotic relationships, generation after generation, leading to further diversification in both. It was a process that also turned out to be a great blessing for mammals. From the beginning, mammals had fed on insects. They were the main source of food to sustain their short lives. After flowering plants changed the landscape, it led to mammals becoming much more diverse, as seen in the fossil record. A tremendous variety of teeth were unearthed. The teeth of mammals adapted to their insect prey. One size did not fit all.
Well, during the late Cretaceous, angiosperms probably became ecologically dominant, became a major component of the vegetation, and with that, insects began to diversify and represent a food item for mammals, a high-energy food item.
It was not just insects that were a new food item for mammals. Flowering plants also brought nutritious seeds and fruits.
And with that ecological diversification of angiosperms, the vegetational structure changed, providing new habitats for mammals to live in and live under and survive away from dinosaurs.
Though mammals remained small in size, their population increased and greatly diversified. Sheer numbers would favor their survival during the age of dinosaurs. 70 million years ago, the competition between dinosaur and mammal was starting to come to an end. But dinos were not giving up yet. More fearsome creatures lay ahead. 130 million years ago, the world was changing, and the ruler of the day was a descendant of the feathered dinosaurs that once ruled Liaoning. Evolution had created the ultimate predator, Tyrannosaurus rex, and North America would be the final battleground between mammal and dinosaur.
So that's been clean.
As night falls at Lake Talcon in northern Florida, Gregory Erickson of Florida State University looks for alligators. He's conducting research to determine the power and strength of North America's mightiest dinosaur by studying their closest living relative. Erickson hopes to capture a good-sized specimen to test out his theories. It helps that alligators are sluggish at night and easier to catch.
Crocodiles are living, what we call archosaurian reptiles. They're the reptiles that are the closest living relatives to dinosaurs. They have very similar tooth structure. For instance, their teeth are down in sockets, or set down in the jaws, very much like our own teeth are. And also the musculature is very similar. So they're really our best model for trying to figure out how bite forces were generated by animals such as Tyrannosaurus rex.
Tyrannosaurus, one of the mightiest carnivorous dinosaurs ever known. Some were almost 20 feet tall and as heavy as 5 tons. Its huge jaw and massive teeth could bite through flesh and bone with tremendous force. Today's alligators may give us an idea of the power of these jaws. It's a 10-foot, 441-pound alligator. No T-Rex, but it might answer some questions about the dinosaur. The gator makes quick work of a deer bone. Erickson will use a pressure gauge to precisely measure the impact of the alligator's bite.
Okay, everybody ready? Probably ready? Here we go. What's that? Here we go. Hang on. Oh, gosh!
2,423 pounds.
Wow! Yeah, he let fly. This is really a really high bite force. The highest bite force ever measured for an American alligator is almost 3,000 pounds, and we're getting a 2,500 pound range here. So this is right up there. It's unbelievable that these animals can generate such incredible bite forces. And the real secret to these animals' ability to generate those incredible bite forces is right here. These are the pterygoid muscles. You can see them billowing out. This is not fat. You can see them bulging as this animal bites. It's just like the bulging of a biceps on a weightlifter. And all of that's going towards applying stress to the bite meter in this case. Based on bite marks from Tyrannosaurus rex, we've estimated bite forces somewhere between 3,000 and 4,000 pounds for a single tooth. Similar situation as this. However, I suspect those bites weren't made at full force.
Combining data from bite marks on bones of T-Rex victims and alligator bite force tests, Erickson estimated the power of a Tyrannosaurus bite at more than 3 tons per square inch, and possibly as much as 9 tons.
Minimally, Tyrannosaurus rex had a bite force of about 6,800 pounds. That's from the bite mark evidence that we have. And that's enough to bite through a car door, no problem. These things could tear up a vehicle, and certainly could tear up just about any animal they got a hold of, I would assume. I think from our crocodilian data, it's safe to say that these animals had bite forces maybe as high as 18,000 pounds or more. So again, just incredible bite forces, among the highest ever generated for any animal.
Their strong jaws were capable of crushing almost anything. If the dinosaur's diet was human flesh, it's estimated that T-Rex would need to dine on 265 grown men a year. Tyrannosaurus rex was the ultimate dinosaur, a killing machine and the result of more than 100 million years of dinosaur evolution. We're still learning a lot about the world's most famous dinosaur. And recently, an unexpected discovery amazed the world, as it shows that T-Rex was descended from feathered dinosaurs. Conclusive evidence was found in the fossil of Dilong, the feathered dinosaur discovered in Liaoning. The cross-section of Dilong's front tooth looks like the letter D. It's a feature unique to Tyrannosaurus and its relatives. Other elements, such as the shape of the skulls, also checked out. Scientists concluded that Tyrannosaurus was a feathered dinosaur. But where were the feathers? Paleontologists believe they were only found on juveniles and lost as the dinosaur matured. So Dilong's North American descendants were only feathered during their youth. No feathers have ever been found on a full-grown adult Tyrannosaurus rex. While evidence of T-Rex as a feathered dinosaur has dramatically changed our image of the carnivore, more recent discoveries are turning upside down many of our beliefs about its behavior, which was mammal-like. Beneath the snow in western Canada's Alberta province lie geological beds 66 million years old in an area they call the Badlands. It's also one of the most important fossil sites in the world. Here, Philip Currie of the University of Alberta, one of the world's leading experts on dinosaurs, made a startling discovery about Tyrannosaurus rex and its relatives. 10 years ago, he carried out an excavation to study a close relative to T-Rex. During the excavation, they unexpectedly found an extraordinary number of bones. Fossils of 22 dinosaurs were buried at one spot. Until then, it was believed that giant carnivorous dinosaurs like Tyrannosaurus lived alone. Currie's discovery showed for the first time that there were giant carnivores living in a pack. Moreover, the group consisted of different ages, ranging from juveniles to mature adults.
Alberta gave us the first evidence that tyrannosaurs traveled in groups. But in recent years, we've also found sites in Montana and in Mongolia to indicate that other tyrannosaurs related to Tyrannosaurus rex, in fact, were probably packing animals as well, and gives us the strongest evidence we have that some types of carnivorous dinosaurs like Albertosaurus were packing animals.
Young Tyrannosauruses, covered in feathers, lived together with grown-ups, armed with the strongest jaws ever. This discovery provided the key to answering some puzzling questions about Tyrannosaurus. Despite its reputation as a ruthless predator and one of the strongest carnivores ever, and possibly capable of speeds up to 25 miles per hour, many believe Tyrannosaurus was just the opposite, a scavenger, burdened by a body incapable of hunting down its prey. Erickson notes the criticisms of T-Rex.
Here's an animal that had these little diminutive arms that, with the tiny claws, how could it possibly kill anything with those? And here we have an animal that doesn't appear to have been particularly agile and doesn't appear to have been particularly swift. How could it possibly have run down prey?
If T-Rex had powerful jaws and tiny, powerless arms, and if its legs were short, so it could only run at slow speed, just under 10 miles per hour, how could T-Rex catch its prey? The answer may be hidden in its bones. This cross-section reveals tree-like rings. By studying the spacing, the annual growth rate can be determined. From birth to early teens, the growth rate was rather slow, but picks up in the mid-teens. The narrow rings to the right show that after the age of 18, the rate of growth suddenly drops. It was only the mid-teens that had such rapid growth. In the first 10 or so years, the body of a Tyrannosaurus was slender, and their hind limbs were long and slim. It's thought that during this juvenile period, the dinosaurs would have been feathered. And then, in their mid-teens, they bulked up at a tremendous rate of 4.4 pounds a day. Feathers disappeared, and jaws grew larger. The legs would become relatively short for their robust new bodies. On the surface, immature juveniles and the mature adults looked like they were completely different animals.
By the time you get up to an 18-year-old, 19-year-old Tyrannosaurus rex, you've got a full-grown, bulked-up animal, a 12 to 15,000-pound elephant-sized creature. It certainly would have, packed a wallop if it got a hold of you, but it probably would have lost a lot of agility by the time it reached that size.
Currie believes that the difference in body shapes according to age holds the key to unlocking the greatest mystery of Tyrannosaurus. How did they hunt?
These packs of tyrannosaurs were composed of both young animals, which were long-legged, fast, agile animals, and the adults, which were large, massive animals with incredible strength. And together they hunted cooperatively and could take down anything they wanted.
On the plains of North America, herds of dinosaurs like Triceratops roamed. Potential prey for a family of hungry predators. Heavily armed, with horns up to 3 feet long, they won't be easy to take down. But the T-Rex family has a few tricks up their sleeves. The hunt begins with the predators hiding behind a grove of trees, waiting to spring into action. Two swift juveniles begin the hunt and chase. The Tyrannosauruses are not blindly running after their prey. They're trying to drive it toward the woods for an ambush. As the herd thunders on, the juveniles focus on a limping animal. It's the law of the jungle, where only the strong survive. And unfortunately for this Triceratops, the most powerful jaws ever are waiting ahead. "30 feet long, 10 feet high, and up to 12 tons. Triceratops is a big meal. The adult gets first choice, but it's a meal for the pack." Both young and adult cooperated to bring down the dinosaur, and the hunting pack made best use of their different body types and abilities. The dinosaurs are now thought to have lived as a family, and even cooperated with each other to take care of the young. What's evolving is a new picture of the king of dinosaurs. T-Rex may not be a cuddly mouse-like mammal, but he lived in a family structure that allowed both mammals and dinosaurs to thrive in the Cretaceous period over 65 million years ago.
In spite of the fact that we know that these were quite fearsome beasts, nevertheless, it was quite evident that they had this family structure at times. And this is something we characteristically only think of mammals doing, or even modern birds, but certainly not reptiles. And yet, we have abundant evidence to show that this was the case with tyrannosaurs.
At the University of California, scientists are studying fossils that shed light on how mammals survived the age of dinosaurs. Mammals, despite their small size, had developed a strategy for survival, and that path is found in the fossilized remains of Cimolestes, a mammal that lived toward the end of the age of dinosaurs. Its jaw was just over an inch, and its whole body is estimated to be about 6 inches long. It was a placental mammal, which gave it the ability to carry its young internally. This was a great evolutionary change, unique to mammals.
Well, during that 150 million years, mammals were fairly small and fairly generalized, but many great innovations were occurring. Live birth via the placenta has several major advantages, one of which is direct nourishment through the mother, as well as protection by the mother, and control of body temperature, allowing for rapid development, which allowed for greater survivability once that animal was born. And that's a strategy that you and I take advantage of to this day.
Mammals originally evolved from a group of reptiles, and it's believed that Adelobacillus, the earliest mammal, laid eggs to reproduce. As seen in today's animals, egg-laying has risks. What happens if they're stolen? Or if heavy rains wash them away or submerge them so the next generation can't survive?
Egg-laying animals like reptiles give birth to less developed animals, and those animals have less of a chance of survival than an animal that's born more developed.
At one point in time, to increase survival chances for offspring, our mammalian ancestors ceased to lay eggs. Instead, they developed a placenta, and that allowed expectant mothers to nourish their offspring internally. C. molestes was the first mammal to be raised and nourished by its mother. Placental mammals were the product of evolutionary changes that enabled the young to grow as big as possible inside their mother, where they could be nurtured for a long period of time. Sheltered from the world, mammals could then maximize their chances of survival and help ensure the continued existence of the next generation.
It is this placental structure that truly distinguishes the placental mammals from all other vertebrates, and that allow them to diversify, to survive, and eventually succeed in the future.
About 65.5 million years ago, an asteroid or meteor about 6 miles across streaked towards Earth. It was the beginning of the end for dinosaurs and many other creatures. Until the very last moment, both dinosaurs and mammals had continued to evolve, though in completely different ways, to ensure the success of future generations.
We know that mammals and dinosaurs coexisted for the entire history of dinosaurs. And this is something most people tend to forget.
Each of them had a great influence on each other. Dinosaurs representing great predators to mammals. Mammals had to find their way in a nocturnal world.
Dinosaurs were not able to move into sort of the small, typically nocturnal niches that we associate with those types of mammals, simply because the mammals were already there. In other words, they were the better competitor for that space.
Were it not for the dominance of the dinosaurs, mammals would have never developed this adaptation. In a way, we ought to thank the dinosaurs for forcing the mammals into such a future evolutionary success.
The landscape could actually hold more of these little mice because they weren't using as much of the resources at any one time. We could hypothetically say that there may have been, say, 5,000 supersaurs over all of North America. Let's say that something happened and 1,000 of the supersaurs died. That may be enough to push the population over and they'd go extinct. Whereas if you were to kill off 1,000 of these little mammals, there was still thousands, maybe even millions still to carry on. And so being small can be advantageous. Being big, although it does have its advantages, can also be a great disadvantage when things are not going well.
$65.5 million years ago, the immediate future was bleak for mammals and dinosaurs as the huge meteor hurtled towards Earth and the Yucatan Peninsula. While mammals foraged for food and dinosaurs rested, shooting stars filled the night sky, foreshadowing the upcoming cataclysm. When the meteor struck, it was sudden death from the heavens. In an instant, dinosaurs had gone from domination to near extinction, unable to cope with their devastated world. An object from space had ended the evolutionary race between mammals and dinosaurs. It was now the beginning of a new age and the rise of mammals.